Hello, let us continue our discussion on the NodeMCU. So, we will talk about SPI interface in NodeMCU. So, SPI stands for Serial Peripheral Interface. As the name indicates, this is a serial interface which transmits data serially over the lines that are dedicated to this serial interface. So if you we already know all this. Interface has four signals, right? Clock, MISO, which is called master in slave out, MOSI, master out slave in, and chip select. So in a SPI, you need a master and a slave. So master initiates the communication interface, master selects the slave, master transmits the clock, and slave responds to the messages that are sent by the master. So master is who initiates everything in SPI. NodeMCU has SPI interface. Actually, SPI interfaces. One is the one which you see here, which has four signals on D5, D6, D7, and D8, the complete SPI interface. And then there is another SPI interface, which is a quad SPI interface, where it is extended on this side. You can see SD0, CMD, SD1, SD2, SD3, and clock. This is a quad SPI interface, and the internal flash, as we discussed in our previous videos, the internal flash is connected to the ESP8266 using these pins. So we don't use this SPI interface externally. So for any communication, we use this SPI interface to talk to the slaves. Now, if we take the slave interface. So as we are using Arduino IDE for coding, let us take Arduino Uno board, which is easy to understand. And Arduino Uno also has SPI interface, right? We have seen in our videos in our channel. And we can interface NodeMCU to the Arduino Uno over the SPI, and NodeMCU can act as a master, Arduino Uno can act as a slave. So we can make this combination, and instead of using some other interface like a SPI display or a memory, we can use the Arduino board itself as a slave and talk to the 80 mega chip that is there on Arduino over the SPI interface. So let us see the code and how the SPI communication happens. Here is the sample code. So first we will talk about the NodeMCU. So we mentioned that NodeMCU we will be using as a slave here, right? So, NodeMCU as a master here and Arduino Uno as a slave, right? So what we are doing is we are first configuring the NodeMCU such that it transfers data continuously to the slave. So the first thing, we have just taken a array here and put it welcome to YouTube channel way to know. Okay, and then we have just taken a variable and we are saying the baud rate will be 9600, and we said SPI begin. So SPI begin is a inbuilt function. So what it does is basically it initializes the master in layout, clock, and chip select signals, and also enables all the signals as output, like clock, MISO, MOSI, and everything as output. So it SPI.begin is an inbuilt function, and then we are trying to count the number of bytes in the array data underscore output. So if you see here, data underscore output is an array, and then the count will have the value of or the size of this array. And in the loop, what we are trying to do is 0 to less than count. We are just trying to run a loop such that we are starting from 0 till the count. That means the length of this array, and transferring byte by byte using SPI.transfer of and data underscore output of I is a variable, and if you have data underscore output of 0, you will be outputting W, and then once the loop increments, data output of 1 will be E. So welcome to YouTube channel, way to know. So will be transmitted byte by byte to the slave. So this is a serial interface, right? You can see we are transferring byte by byte. So that's the simple code of NodeMCU. Now we will talk about the code of Arduino and see how it looks like. Okay, so this is Arduino code. Here, Arduino is the slave, right? We said char underscore data received. This is a array which is declared of size 100. You can increase the size based on the data that you are going to transmit, and then you have a counter again here, and then receive complete. This is a complete flag. So once the data is transmitted out, or once the data is received by this particular Arduino, the receive flag will be made high. So in the setup, what we are doing is we are setting the serial baud rate, and then we have enabled the SPI interface, and this SPI we are enabling Arduino as a slave here by enabling the bit SPE, and we are making this MISO as the output, and you can see count we are making it 0, and receive complete as 0. These are the initial values, and then we are enabling the interrupt. So after enabling the interrupt, the next step would be the loop, which is basically what we are doing in the loop is we are just trying to check if receive complete is high. That means if receive complete is 1, the if loop gets satisfied, and then it goes inside, prints the data received, whatever is received, and we are making the data received of count 0. So entire array 0 again, and initializing count and receive complete. Okay, so we are bringing back these values. So where is actually data being received is in this interrupt. So there is a SP interrupt routine here. This is basically called interrupt service routine ISR, and the interrupt service routine vector you can see here is already defined internally. So if interrupt occurs on SPI, this the control will come to this interrupt routine, and we are going to pass this register value to a variable, and this CLI is a memory function. So you can study more about this in the manual, and what we are doing is basically we are trying to read the data, the SPDR. This is the register where the serial data will be received. We are trying to input this data to a variable, and what we are doing is we are just so initially the count is 0, right? If the count is less than size of byte received, what we are doing is we are putting that variable into the array, and we are trying to receive until /n, which is basically the new line character is received. So if we go to the previous NodeMCU code, we are sending a new line character at the end. You can also send 88, you can also send hash as per your protocol requirement. We are sending hash n. So if it is the new line character, we are saying receive complete. Once the receive complete is enabled, it prints the entire serial data. This is how the entire slave code of Arduino Uno is. We'll be posting this code in our portal. Please check if you have any questions. So now if you see here, We are just trying to power up the board, and then what we are going to do is we are going to go to tools of Arduino, go to serial monitor. You can see the data coming up. Wow. So this will be passed only when receive complete is high. Remember that we are not directly printing anything. So, and then you can see this guy doesn't even know what is welcome to where to know unless this guy transmits it. So you can see the data continuously. The master is sending continuously. The receiver, the slave is receiving the data, and it is printing of the on the serial port. So this, as we talked in the PPT, we are enabling the master and slave communication. SBI master is the NodeMCU, slave is the Arduino. So hope you're clear. Please post if you have any questions. Thank you.